Now for this lesson we're going to talk about numbering systems. It is beneficial to know this, particularly in Ethernet technology. Areas of memory utilized in communication. What do we have? Boolean, or 1 bit of memory, is the smallest area you can have. Value 0 or 1. A byte. This consists of 8 bits and has a maximum decimal value of 255. An integer or word consists of 16 bits with a decimal value of -32768 to +32767 if all the bits are 1. As you see, there is a relationship here between binary and decimal, and a double integer is 32 bits. Just to show an example, here we are showing 1 byte, in other words 8 bits. Now if all those bits are 1, each bit has a decimal value. The first bit is 1, the second bit is 2, the third bit is 4, 8, 16, 32, 64, 128. What you can see here is a pattern. Each bit doubles in value. 1, 2, 4, 8, 16, 32, 64, 128. If you total that, it comes to 255. Some of you may have seen this in a subnet mask, for instance. There is another example where some of the bits are 0. The first 3 bits are a 1, then we have a 0, then a 1, a 0, 0, 1. The only ones you are concerned about are the ones that are showing a 1. To see the decimal values, that is 1 plus 2 plus 4 plus 16 plus 128, and the total is 151. So that's showing you relationship between the bits and their decimal values. This is just 1 byte shown here, but the same rules apply even if you are using a full integer of 16 bits. For instance, the next one after this last bit on the left, 128, the next one will be 256. The one after that will be 512, and so it will go on right up to bit 16. So that is how you can calculate the value of a byte or a word that's in binary, shown in binary, and the actual value of those bits in decimal. Very important. Then we get to hexadecimal. Now, hexadecimal is used extensively in Ethernet communication. The actual word we have here is split into 2 memory allocations of 4 bits, which is also called a nibble. The hex values 0 to 9 is 0 to 9, just like decimal. When it gets to 10, it becomes alphabetical. 10 is A, 11 B, 12 C, 13 D, 14 is E, and 15 is F. 15 is the maximum value you can get in a nibble. So let us see what these values are in hexadecimal. This is 19 in decimal. There's nothing in there. This is 143 in decimal, and this is 239 in decimal. What are they in hexadecimal? That is 3. That is 1. The next one is 0, 0. The next one is F, because you have a total decimal value here of 15. The next one is 8. Then we go to the next one, which again is F. And then the next one is E. So how would it look written? It would look like that. EF 8F 0013. Now this is used extensively when we talk about MAC addresses, which are always displayed in hexadecimal. So here you have the display for the entire word, and it's used to display addresses of devices in hexadecimal format as a MAC address, which we will be discussing later in the course. So I really hope this helps you. I know a lot of people still don't understand numbering systems. And there is another thing to remember as well. All Ethernet communication and computers can only see zeros and ones. Nothing else, even though what you see on your screen is certainly not zeros and ones. So I hope this lesson's been useful to you. Thank you.